Hi, everybody. My name is Tom DiLiberto. I'm the media director here at Climate Central. And excited to have you here all today to talk about this new uh, resource from Climate Central, our latest daily attribution resource called the Climate Shift Index Humid Heat. Just so everyone knows, this webinar is being recorded. And if you've registered for this webinar, we will make sure that we email out that link to everyone after the call. So why are we here? Well, extreme heat is an incredibly dangerous thing. In fact, it's the deadliest weather-related hazard in the United States and has claimed more than 250,000 of lives globally since 2000. But as the saying goes, it's not the heat, it's the humidity. With that in mind, Climate Central has published new research and expanded its climate shift index system with the release of this new resource, the Climate Shift Index Humid Heat. In real time, it's now possible to see how climate change is driving increasing health risks associated with humid heat for communities across the globe. During today's webinar, you're going to hear from a variety of experts who will discuss this latest research. They're going to walk you through the climate shift index, humid heat. They're going to dig deeper on the health risks associated with humid heat and also explore the many, many potential stories that can be told using this work. And our experts today, we have Caitlin Trudeau, who's an applied climate scientist at Climate Central, Dr. Lisa Patel, who's a pediatrician and the executive director of the Medical Society Consortium on Climate and Health. We have Shel Winkley, who's the senior engagement specialist and a meteorologist here at Climate Central, and Chase Kane, who's a meteorologist with Chase What's Matters. Now, after the presentations, we're going to open this up for questions from the audience here. The key way of doing that is to add your questions via the Q&A feature at the bottom of your Zoom screen. I'm going to mention that multiple times, so folks know. Feel free to get your questions whenever they pop into your head, but we'll cover them at the end after the presentations are over. Also, as a note, we have Daniel Guilford, a climate scientist from Climate Central, who's also going to be around to help answer any questions that are submitted through the Q&A feature. We'll either do them, we'll type out answers in the Q&A, or we'll answer them verbally at the end of the presentation. Now, to get started, it's my honor and pleasure to introduce Caitlin Trudeau, who is the first author on the paper, who will go over all things that we want to know about this new resource. Caitlin?
Thanks. What a setup. Thanks, Tom. Okay, so my name's Caitlin Trudeau. I'm an applied climate scientist here at Climate Central. I've been here about 8 years, and part of that time here has been studying humid heat. And I just want to acknowledge from the top here that this was a massive effort from basically the entire organization. So I just really want to acknowledge that just a ton of work has been done on this, and just express my gratitude to everyone. Um, so some of you may be familiar with our climate shift index. Back in 2022, that's when we first announced that we had this climate shift index tool. It was just for air temperature, but it was really exciting because it was one of the first times you could really look anywhere in the world. You could look at any temperature and you could understand how human-caused climate change made that temperature more or less likely, more intense, less intense. And that we've really built it out ever since then. A couple years later, we released our Climate Shift Index Ocean, which looks at sea surface temperatures. We also now can look at tropical cyclones and look at how climate change has increased the intensity of certain storms. So this has been a product we've been developing for many years, and it's really been an honor to be a part of it. So that's kind of how we got here. And today we are introducing the newest member of this Climate Shift Index family, which is Climate Shift Index Humid Heat. And this basically quantifies the influence of climate change on daily humid heat and related health risks around the globe. Like all of our CSI products, this is based on peer-reviewed science. And just today, we have a new paper out in Environmental Research Letters that basically demonstrates our methodology. And it shows that a climate fingerprint is not only something that we can identify, but it's something we can actually quantify around the world. We looked at 4 different case studies of humid heat events from all around the world to show that climate change is making humid heat more intense and much, much more likely in many cases. So I encourage everyone to check that out as well. But what we're doing here in this paper and what we do across all of our CSI products is we're really comparing the probability of a given event in a world with climate change versus a world without climate change. And we're just basically talking about how much more or less likely this event is because of essentially carbon pollution. And I just want to just first talk about why humid heat. And not all heat is created equal. So I am here out on the West Coast. I'm in California. When I see extreme heat here, it is very, very dry, very hot, but very dry. Most of my colleagues live out on the East Coast, and when they have a high heat, they have a lot of humidity. And so it's really that humid heat that's super dangerous for us because humid heat actually interferes with our body's primary like defense system against extreme heat, which is sweating. And so the more humid that the air is, the harder it is for us to evaporate sweat. And that kind of leaves this heat that our body's trying to desperately shed kind of trapped inside of our body. And standard thermometers can't really capture that heat that's kind of hidden in humidity. So standard thermometers, we look at, sensible heat. They can tell you what the temperature is, but they can't tell you the full burden that's actually on your body. So, thinking about how we're moving forward into a world where climate change is making the world hotter and more humid, it's really important that we look at something besides just temperature because that's only going to give us part of the picture. And that's why humid heat is often overlooked and often under-discussed in many situations. So our tool is really built on a metric called wet bulb temperature. And really what it is, it's a combined measure of temperature and humidity that really represents the lowest temperature that a surface can reach through evaporative cooling. For us humans, that basically means how effectively we can cool our bodies through sweating. Um, and this is really important for a lot of reasons, but it used to be thought that there was this survivability threshold of about, 35 degrees Celsius, 95 degrees Fahrenheit, where past that point, our bodies would basically shut down. We would not be able to sweat anymore, and it would basically put our lives at risk. Um, but as time has gone on, we've done more research. We've really learned that critical thresholds are actually much, much lower than that. And for the most vulnerable populations, they can be very low. And so it really depends on your age, your health conditions, your activity level, and your access to cooling, things like that. As you'll see in our tool, we use a threshold of about 77 degrees Fahrenheit to be what we call dangerous humid heat. And I know that sounds really low to a lot of people, but I encourage you to just remember it's not air temperature that we're talking about. And a wet bulb temperature of 77 degrees Fahrenheit could actually mean two really different things. So here's just an example. You have on the left side of your screen an environment with about 105 degrees Fahrenheit, relative humidity is about 26%. And then on the right side, much different environment where you have temperature about 80 degrees and a relative humidity of about 88%. So both of these situations would be valid to have a wet bulb temperature of 77 degrees Fahrenheit. So I just really want to underscore that, they may look very different on a thermometer, but it's really the same risk to your body. And that's why this is also very important. There are so many different types of humid heat indices, and probably more than I could have ever cared to dream of. But you're probably more familiar with a couple other ones that we decided not to use. So heat index is the one that's most widely used in weather alerts, and people are probably most familiar with. It measures, or it's a model of air temperature and humidity. But it's more designed to capture perceived comfort and not physiological stress despite it being pretty intuitive and widely used. Wet bulb globe temperature, which is not the same as wet bulb temperature, is actually just a more comprehensive measure of heat stress. So in addition to air temperature and humidity, it also takes into account sun angle and wind, and it kind of accounts for that full environmental exposure picture. So it's a lot more comprehensive. But what makes it more comprehensive actually makes it harder to use for something like attribution because these additional components make it really difficult to isolate the climate signal because, sun angle and wind aren't as directly tied to increasing greenhouse gas emissions like temperature and humidity. So those are just some of the background as to why we chose wet bulb temperature. It's a really great example of this kind of middle ground, but it also is just so directly relevant to our bodies and our ability to sweat. And before I pass this off to Lisa, I just really want to just underscore why this matters and why I'm just so excited to be a part of this project. Humid heat is very, very deadly, but we don't talk about it as much as other types of heat, like extreme dry heat, for example. And I think that this tool, what's so great about it is that it can help tell a story that people may not realize that they're living already. And that's what's so important here is that as our world gets hotter and stickier, it's just going to become more urgent for people to be able to communicate where these risks exist and how they are changing and what people can actually do about it. So now I'm going to hand it off to Lisa and happy to answer questions at the end.
Thank you, Caitlin. Yes, we're going to hand it now off to Dr. Lisa Patel, who's going to talk us more about why all this matters, what the risks for humid heat are on human health. Again, Lisa is a pediatrician and the executive director of the Medical Society Consortium on Climate and Health. Lisa?
Thanks so much, Shell. My screen blocks out for 1 second while it uploads. All right, here we go. Thank you so much, Caitlin, and you set me up really nicely to talk more specifically about why this is a health threat and how that turns up in terms of patient stories and health that we're seeing. I'm a practicing pediatrician. I work at a small community hospital where we are experiencing more of these heat events. I also grew up in Houston, so I can tell you that contrast between the dry heat that Caitlin was talking about in the Bay Area versus that hot and humid heat in places like the South and the Southeast. But Caitlin really nicely outlined how these types of prolonged heat temperatures, what they can mean in terms of the human body and why this is so important from a physiological point of view. I'll say one more thing about it. So our bodies just have one physiologic mechanism to cool down. There are behavioral things we can do, like we can go into shade or we can go into a cooler place. We can shed a layer of clothing. But our bodies only can do one thing themselves to cool down, which is to sweat. And what happens is our body needs a specific temperature to be able to operate well. On a very molecular level, everything that happens needs a specific range of temperature to perform its duties. So when that temperature gets outside the range, when it gets too hot, your body starts to send that blood to your skin, to the periphery, so that it can cool down. And so how I like to describe sweating, it's kind of like a sprinkler system. So that hot blood comes to the surface, releases the heat. With that, it can release some moisture as well to cool the body down. But if the surrounding air is already filled with so much moisture because of the humidity, there's nowhere for that water in your body to go. So you essentially can't sweat. So if you lose that ability to cool down, well, that heated blood just goes back into your body, but your body doesn't know what else to do. So it'll just keep pumping that blood out. And as that happens, less blood is going to the organs in your body. So you start to feel dizzy, you start to feel nauseous. If this goes on and on, it can end up in organ damage. Heat illness can result in heat stress and heat stroke ultimately. As Caitlin pointed out, there are places like there's the dry heat, and our bodies can handle the dry heat a little bit better in a way because that is the environment in which we can sweat and we can cool ourselves down. But in humid places where the air is already filled with moisture, that is harder for us to do. And as Caitlin mentions, that it's those humid places that are extraordinarily dangerous because at a perceived lower temperature but higher humidity, you're actually at higher risk because you lose that ability for your body to cool itself down. In terms of what I see in the hospital and how this plays out, we are seeing more outdoor workers who are at higher risk of heat illness and heat stroke. I cared for a 16-year-old patient who was working at a construction site on a very hot day, wasn't getting shade, wasn't getting the water breaks that he needed, came in with kidney damage. I work with, and that was easy to reverse because he's 16 years old. So we aggressively hydrate him, and that makes it better for him. I work with emergency medicine colleagues who will tell me that they will have workers come in frank kidney failure because they will have taken hit after hit after hit to their kidneys, not recognize that damage is happening, and then come in essentially needing dialysis. We should be additionally concerned about this because we don't have, in many states in the US at least, we don't have worker protections in place. And places like Texas and Florida, they're not allowed to pass worker protections. And so we know as things get hotter and more humid, that workers need those breaks and they're not getting those protections. Athletes, heat is actually the number one preventable reason why athletes die in this country. And again, if you look at which athletes are at higher risk, it is in those hot and humid conditions where an athlete may not have had time to acclimatize and their bodies haven't had time to adapt. Football players in particular are at very high risk because in addition to the heat and humidity, they're also wearing that really heavy equipment. And especially youth athletes may not be able to ask their coach if they can have some time off or go to the shade. And so it becomes especially important to make sure that they have protections and training in place. Incarcerated individuals, many prisons in the US and globally lack adequate cooling. And then we are seeing a frank crisis in terms of individuals who are unhoused during periods of extreme heat. This is more about burn units in the Southwest. It has less to do with humidity, but what we are seeing is that people without access to mechanisms to cool down or places to stay cool will be at higher risk. In the hospital, it's an unfortunate, but we do have to count deaths. We do have to write death certificates when someone comes in and dies as a result of what happened to them on the outside. We're not trained as physicians to be talking about if it's a hot day in terms of a risk factor. So in the moment, heat deaths are often severely undercounted. It's only when you go back in studies and look at if there were excess deaths from heat that you can go back and say, oh, many more people actually died. But counties are often just counting if it's very apparent to them. So if it's an unhoused individual or an elderly person that you found in a hot apartment, but we know that that's a real undercount in terms of the effects of extreme heat. So in terms of the spectrum of heat-related illnesses, and as Caitlin mentioned, heat is the number one weather-related killer, but it is often a silent one, so people are not thinking about it. I do a lot of community talks, especially in communities that are made vulnerable from structural factors like poverty and racism. And a father said to me that he and his son were walking on a street one day and there wasn't a lot of shade and he started vomiting. They didn't know what was wrong. They called 911. And after he heard my talk, he realized that his son had heat illness. It didn't occur to them at the time that some water, some rest in the shade could have prevented something like that from happening. So the symptoms of heat illness, heat cramps, heat exhaustion, headache, flushed skin, as I mentioned, that can go on to heat stroke, which is a life-threatening medical emergency. People with chronic medical conditions are at higher risk. So as I mentioned, when your heart starts to, when you get hot and your body gets overheated, you start to pump blood out to the periphery. Well, to cool you down, your heart will beat faster and faster to pump that blood out. You can imagine an older heart or a heart that's already had a heart attack, for example, a weaker heart. The longer it has to beat faster, the more strain it is on those hearts. And that's often why you see people that are elderly might die the first or second day after a heat wave has begun because that stress on their heart accumulates. The mental health impacts. And so this is an emerging area. There's evidence that shows correlation during periods of extreme heat. So things like increased interpersonal violence, anxiety and depression, and increased suicidality. Pregnancy, this is actually very well documented in the literature. Low birth weight and premature birth are risk factors. And then disrupted sleep. We do not sleep well when it's hotter outside, and that poor sleep can accumulate into chronic medical conditions down the line. Oops. Some of the protective interventions are things like water and shade breaks. What we're starting to see in places in the Middle East is that they're shifting the entire workday to times of day that are cooler. We can do environmental controls, so ensuring access to air conditioning. And then we also need to make sure that that families, communities can actually afford their energy bills. It has become my standard practice to ask every family with a newborn leaving the hospital whether they have access to air conditioning and whether they can afford to run their air conditioning. And I have screened 2 families positive where they did not have access to air conditioning or they couldn't afford to pay their bills. I'm not going to send that family with their newborn home to a 110-degree apartment, because infants are at higher risk for mortality in that first week of life if they don't have access to a cool environment to sleep and to rest. So, as mentioned, heat is the number one weather-related killer. It's often a silent and under-recognized risk. I'm really grateful for this tool. I think it's going to help us tell better stories, and it will help raise awareness amongst health professionals as well, to be counseling our patients on the risks of heat and humidity and how to physiologically adapt. And I'll turn it over to the next speaker.
Thank you, Lisa, very much for that. Next speaker we have is Shel Winkley, who's going to walk us through the tool itself. Shel is a senior engagement specialist and a meteorologist here at Climate Central.
Yeah. Thanks, Tom. Yeah, so strap in. We're going to take a tour of the Climate Shift Index Humid Heat tool that is available as of today on the Climate Central website. So this is what it is. If you're familiar with any of our Climate Shift Index products, you'll likely be able to walk around this pretty easily, but I want to kind of just step you through what you'll find, what you can use, and then how you can share this, especially with viewers, with readers, with followers. So this is today's dangerous humid heat signal. This is what you're going to encounter when you first come to the map. Here for May 12th, 2026, you can see that there is a bit of a humid heat severe signal, or dangerous signal, if you will, in parts of Mexico, but especially up here in northern portions of South America, along the Ivory Coast, and in some of the chocolate growing regions of Africa as well. So essentially what you're looking at here, and we'll come into South America. When you see the pink color, that is where this dangerous humid heat, which is a threshold of 25 degrees Celsius or higher for that wet bulb temperature that Caitlin was telling you about. This is where that threshold was essentially crossed, or where we come into this area where those health risks are possible for different groups due to climate change. And then you'll also find these orange colors. That is where it would have occurred anyway. We do it, and I'll show you how you can see just how climate change has really made a wet bulb temperature that puts you in a certain position for your health to be impacted. So that is still possible here in this orange color, but it's likely that we would have occurred anyway, with some amplification, most likely because of climate change in some certain situations. So one of the things, at least for me, 25 degrees Celsius, if you can't do that mental math in your head, one way that we can easily change that over, here on the left-hand side, your temperature units, you can toggle between Celsius or Fahrenheit. So we know that that 25 degrees Celsius equates to 77 degrees Fahrenheit or higher when it comes to your wet bulb temperature. I want to actually, so one thing that we can do is you can come to your date here on the left-hand side. You can also search your city name or locate yourself. But because we are building this off wet bulb temperature, like we can do with our air temperature or land temperature for the climate shift index, we can also utilize the GFS forecast to forecast days ahead. So maybe that's relevant here in the United States, because we know that the National Weather Service has issued a excessive heat watch, specifically for the fact that we're going to have maybe a high heat index or high humidity that can cause that heat stress and that heat illness potential. So if you have that coming, you can actually use this tool to look ahead up to 3 to 4 days out, to understand that climate signal, and if there is a climate signal that comes along with that heat. So because we don't see a whole lot in the United States, what I want to do for the rest of this walkthrough is I'm actually going to come back here to let's go back to the first day of summer last year. So June 21st, 2025. And you can see here across portions of the Gulf Coast region down to Florida, up into the southeastern US, but specifically anywhere from Mississippi, Arkansas, Missouri, into Chicago. Again, we can see where this threshold has been crossed and where it is more likely because of climate change. So that's anywhere from down here in Texas up into Kansas City, Des Moines, Iowa, Minneapolis, Minnesota, and even approaching Chicago. So we can find a place, let's say, let's pick Kansas City. So the other way that you can get information from this is if you don't pick a city specific, you can right click on the map, and that will bring up this card on the side. So what this is going to tell you is kind of everything that you need to know. Climate change has made the daily high wet bulb temperature at this location, so Kansas City, at least 10 times more likely with that wet bulb temperature being 77.6 degrees. So maybe you want to vet this a little bit more and really look at that climate signal altogether. This tells you that heat or that health metric. This is what you would normally find, again, if you're familiar with the climate shift index. This is the time is more likely. And so here in Kansas City, you can see how that correlates to that 10 times more likely. So you can almost use this as a understanding of how climate change is impacting it and how much more likely this wet bulb temperature, this humid heat signal might be. And the other thing that you can do here on the legend, it goes from 0 to 150. You can scroll over the legend and you can understand the colors just by moving your mouse over the top of it. And then if you want to just really dive into the wet bulb temperature, we also have that here for you as well. You can look and you can see the wet bulb temperature across the United States here on June 21st, 2025. I want to put a pin here just to show you how we can bring this together. So for me as a meteorologist, when I'm looking at this severe and dangerous humid heat signal, to me, this shows me, okay, if we've got this funnel of moisture that looks like it's coming out of the Gulf of Mexico up to the north, what's the weather pattern that's causing it? So I went ahead and I pulled up the weather pattern for June 21st, and we've got high pressure at the surface over the East Coast. We've got high pressure over the southeastern US that's bringing that clockwise flow out of the Gulf of Mexico. And so this is where our climate shift index really can tie together, right? So we have an ocean climate shift index that quantifies climate change's influence on unusually warm sea surface temperatures. And so if we come to that again for June 21st, 2025, and again, we can right click, we can understand that the ocean temperatures that's allowing more of this moisture to then move into the United States, is made anywhere as much as 70 to 100 times more likely for those warmer ocean temperatures due to climate change. So that's how you can kind of work all of this together to really tell the comprehensive climate story. The last thing that I'll leave you with here for climate shift index is a couple different things. One, if you want to toggle very easily here at the left-hand side, you'll see the air temperature as well as the climate shift index ocean. So you can toggle between our different climate shift index systems and tools that we have right there. And then let's say you want to share this. You want to get a simple image that you can share with your viewers, with your readers. Maybe you're creating some social media from it. So here on the top right-hand side of the screen, you'll see two yellow buttons. If you click the screenshot map, and this works across all of our climate shift index maps, you'll be able to download and move around as you need to, but we've got three different versions for you. So we've got a standard square version for most of our short form social medias, your X, your threads, things like that. And then we've got a landscape version, a 16:9, that's going to be broadcast ready or maybe better for digital print. And then if you want to do your social media with it as well, you can come to portrait mode down here at the bottom, and it gives you a vertical 16:9 that you can use for your short form videos or maybe your Instagram stories or Facebook stories as well. And then you just click the download button here. It'll download for you and it'll be ready to share and be able to tell these health stories around the humid heat signal on any given day globally across the United States.
Thank you, Shell, for showing everyone around the tool. Our last speaker, who's going to talk a little bit more about how to tell this story. Happy to have Chase Kane from Chase What's Matter. So Chase, take it away.
Hello, everyone. I'm making sure that my screen sharing is working. My screen froze. Happy to be with all of you. I am also a meteorologist, also a reporter for more than 20 years. So I want to talk about some ways to consider humid heat, how you might explain that, communicate that to your audience, and hopefully some story ideas as well as I go through the presentation. So let me start sharing here. So the first thing before we get into story ideas is that I just wanted to talk about clarity and understanding for your audience because there are lots of terms here: dew point, relative humidity, heat index, wet bulb temperature, wet bulb globe temperature. And so it might be confusing for your audience. And so, especially for the meteorologists, I would just encourage you to consider what's the best term that you can simply use to explain what's happening. And maybe that's not wet bulb temperature. Maybe you refer it to something else, like simply humid heat. I would sort of raise the question, like, should you even say wet bulb temperature on air or on social media? My perspective would be only if you actually have time to explain to the audience what that means. And when I was doing research for this presentation, I saw a number of folks on TV and in written articles talking about wet bulb events, essentially a humid heat wave. And I was thinking, gosh, who beyond a meteorologist or maybe a health professional understands what a wet bulb event is? I think simply a humid heat wave is probably a better phrase, or maybe even more effective is a humid heat wave which threatens your health. So it's just something for you to consider with your producer, with your editor, as you're figuring out how to communicate this. I also just want to emphasize that this is not just a Florida and Texas story, that these dangerous wet bulb temperatures of 77, 80 degrees plus have happened in, New York, Chicago, Detroit, Minneapolis, lots of places other than just the Deep South. And this is a screenshot today of the humid heat signal for the Western US. So even though most of those wet bulb temperatures aren't dangerous, you are seeing places across the West that are experiencing humid heat because of climate change, that there is a signal there. If you are in an agricultural region, especially as we get into July and August, maybe a story around corn sweat would be an interesting way to get your viewers involved in this, because corn sweat, of course, occurs naturally from the evapotranspiration, the water vapor that's being released from corn, but that is also being amplified by climate change as we get more moisture, as we get higher temperatures. It can also happen in the desert Southwest, in Arizona and Southern California, once you get into those monsoonal flows. So I want to rewind to a story that I did 2024. Hopefully this will give you a couple of different story ideas of things that you could talk about in your community.
So Chase, your slides,
Yep.
can you go into presentation mode? Your slides aren't
Oh,
updated.
they're not up. Thank you for clarifying that for me. Okay, do you see the slides now?
Yep, slides are good.
Okay, I will just go back to this quickly since you didn't see the slide, but just to remind everyone that there is a climate signal with humid heat in the Western US. Okay, I will click play. Let me know if you're not hearing audio on this.
For example, official records count roughly 2,300 heat-related deaths last year, with more than 3/4 of them from these 6 states. But a study from Texas A&M projects the actual number could be 4 times greater, possibly 11,000 Americans dying from extreme heat last year. But why such a big difference?
One of the big challenges in medicine is understanding why is a patient in front of you. With heat, it can be complicated.
Dr. Gupta is an NBC News medical contributor and pulmonologist at the University of Washington. He explains that heat can cause or trigger so many different health problems, it can be challenging for doctors to untangle the root cause.
We don't often talk about heat as a direct killer. That's really important. The more that we are talking about this, the more it makes clinicians more aware that this is a problem, because it's going to allow us to better understand.
Okay, that
For
kind of early
example,
for some reason. Maybe it was my
level
internet, but I'll
of
jump ahead here
every
and catch
single
back up.
track
Sorry about that.
heat-related deaths.
And without that granular level of examining every single one of thousands of data points, you really don't get that level of detail. So really the numbers that we have are the most conservative numbers. And even then, those are trending upward.
Trending upward since 2016, right along with our temperatures. The 10 hottest years on record have been the last 10 years, largely because of climate change.
So hopefully 2 takeaways there. One is how to talk about humid heat in the context of climate change, and certainly linking it to the hottest years on record is an easy way to do that, but this new Climate Central tool should make it even easier for you. The other important thing is that every city, every county, every state has different ways of tracking and measuring heat-related illnesses and heat-related deaths, and often they're not actually counting a death as connected to heat. So again, that's something that is leading to really an underestimation of just how bad this problem is. So I think that is an important story that essentially everyone could tell this summer. Also with this next slide, not picking on anyone if you see your outlet up here, but I wanted to just raise this question for you to consider when you're talking about whether it's humid heat, dry heat, when you're talking about dangerous heat. Consider the visuals, the video that you're using, because showing children playing in a fountain or at a playground or eating ice cream maybe doesn't communicate the full risk, especially to our health here of heat. So just something to consider with your producers and editors as you're talking about this subject. Also, this isn't directly related to the humid heat tool, but I thought this was an interesting way that you might be able to, even without leaving the studio or the newsroom, be able to explain some of these different terms to your audience.
Let's do an experiment. Take these 2 containers. Each represents a column of the atmosphere. The taller one, a glass of warm air, and the smaller one, cooler air. I fill each halfway. That's like 50% relative humidity. Now, even though both have the same relative humidities, the dew points, which represent the actual amount of water vapor in the air, are different. The warmer air has a greater dew point, which means the air will feel more uncomfortable.
And so, yes, that took a little bit of work to pre-produce, but I think it's something to start thinking about now because so many of us know that we're going to face humid heat this summer. So if you can start working on an explainer like this when you have a slow day, when it's just nice, calm weather, I think that could be really helpful to your audience, especially in the days leading up to one of these humid heat waves. This is another way to think about
so this is an experiment. You can easily do at home. I don't even know if I would call it an experiment, but this is how you can see the cooling process. So I'm going to spray your hand with some water. All you're going to have to do is just go, and you can feel it naturally cooling on your skin. So blowing on your skin essentially is it evaporating off. The water turns to water vapor. It evaporates just like our sweat, cooling us down. However, in the summertime, we have the sweat. However, there's a barrier in between the air and the sweat, so it's not able to evaporate.
And the barrier she's referencing there is just the fact that there is a lot of humidity in the air, so it makes it less likely or it makes it more difficult for your body to cool off through evaporation. But I just thought that was an easy, simple way with a little spray bottle for a meteorologist to also involve the anchor, or if a reporter is working with a meteorologist, that it could be a little bit more interactive. This was also kind of a funny example of interactive, but I also wanted to share this with you. If you are not familiar with the original tool for how to measure wet bulb temperature, it's called a sling psychrometer. I'm not going to say that 3 times fast.
Bulb temperature.
Right.
Oh, what is this? Is water?
So we just dip it in water.
Oh, man.
And now we sling it around. And basically you wait until that water evaporates.
Yep.
And
That's cooling
yes.
the temperature.
Just like when you sweat, it helps cool you down. So that will cool the temperature down.
Is that ever flung off?
Not in my so now it cools it down to.
So the anchor was a little afraid of the sling psychrometer, but I also just thought that was an interesting way to like really go directly to the idea, the science behind this in a way that engages different members of your newsroom. One last thing that I actually did not consider until, again, I was doing research on this is how humidity and the air temperature, wet bulb temperature, can also impact things outside of summer and spring and fall as well.
Colorado air. Perfect example here. Wednesday morning, it's almost 10 o'clock and the sun is shining bright here at Copper Mountain. The air temperature is up to 36 degrees, well warmer than the freezing point for water, and yet they are still turning water into snow because the relative humidity is only 46%, which makes the wet bulb temperature 28.7. Still plenty of time to make some snow.
Oh yeah.
So again, that's just another way to think about this outside of the dangerous season to, again, help just communicating what this idea is to your audience, especially when the threat isn't present, because that might be the time that they're more able to process the information rather than just thinking about, oh my gosh, it's going to be so hot and humid today. How does that change my life? How does that change my day? So last thing just to kind of circle back to is this idea, because it came up in the chat, of your local health department. How do they track? Do they even have guidance in terms of how a doctor or a hospital should track a heat illness or track heat deaths? I think that's rich, fertile ground for storytelling. And last thing, quick plug here, launching my YouTube channel in a couple of weeks. And one of the first stories will be about humid heat. So that is where to find me if you would like to subscribe and follow along. And I will pass it back over to Tom.
Thank you, Chase. In fact, I'd like to ask all of our speakers to turn their cameras on. Thank you very, very much for this really interesting presentations. We are now going to move into the question and answer portion of our webinar. So if you have that question, make sure you get it asked so it can be answered. Feel free to put it down in the Q&A box on the bottom. Now, I know this one question has actually, to kick us off, has already been answered, but I think it's a really good question that I would like to make sure everyone can hear this answer of. And I think, Lisa, you answered this in the Q&A box. It's around this idea that, you know, different areas adapt differently to heat thresholds, and also this idea between humid heat thresholds varying from place to place. Let's say between a person who's living in Houston versus Boston versus Phoenix. Can you go a little bit more and talk about how the human body can adapt and some of the issues related to humid heat in these different locations?
Yeah, it's such a good question, and as all things, as I think that this seminar has shown us, is that the human body is complicated, and so there's a lot of nuance to this. Populations can adapt over time to increasing heat, in particular, and so the what somebody can handle in a place like Houston or Atlanta is going to be different than what somebody can handle in a place like San Francisco. But there are a few qualifiers to this. So first is your body still needs some time to adapt. Whether the population is adapted or not, it takes some time when the temperatures start to get warmer for the whole population to adapt. So where we see a lot of the harm or the deaths or when the temperatures swing wildly. And we're starting to see a lot more of that happen with climate change. So in the springtime, it gets very dangerous because our bodies aren't adapted yet. We're behaviorally not adapted yet, and the temperature can swing, and especially an older body or a very young one or somebody with a chronic medical condition is more vulnerable during those periods of time. But the second piece of this too is also an infrastructure question. So if you look at how many people have access to air conditioning in the Pacific Northwest, it's something like 60 or 70% versus a much higher coverage in places in the South. And that's because some parts of the US have never needed air conditioning in the past. So there are infrastructure items as well that make some places better adapted than others. But linked into all of this is the fact that with humidity, we lose a major tool in our toolbox to cool down that you don't need infrastructure for, and that's sweating. So when you lose the ability to sweat, that becomes a major factor in outcomes across the board.
Thanks, Lisa. And I know we also got a bunch of questions in the chat around the tool itself in terms of being able to get information for specific locations. I don't know, Shell, if you wanted to share your screen again, maybe show a little bit more about how you can walk around and get specific information for specific locations.
Yeah, so we'll bring it back up. So we'll use that. I think it's going to share here eventually. There we go. So we'll use the June 21st, 2025 example again. So if we want to look specifically at Minneapolis, so we'll come in and we'll find Minneapolis in the list. You can toggle down, so we'll click on there, and then the map will automatically zoom in. This is about as close as you're going to be able to get, but it'll zoom in, and then when you want to pull out that specific number, we can see that there is this dangerous humid heat signal that is due to climate change here in Minneapolis. So we'll be able to pull some of that information out in this card. So people are here experience dangerous humid heat due to climate change. That's your, I guess, qualifying, yes, this is a climate change signal that we can say with certainty that this is climate change. And then if you want to pull out that attribution number that comes along with it, that's in the second toggle here to really understand climate change's role and how much more likely that wet bulb temperature being in this threshold is. You can use the card here on the right-hand side, or you can come over back to this toggle on the left-hand side and also see it as well. And again, that's where you can scroll over the legend if you need a little more help to really understand how many times more likely that humid heat signal was. And I think earlier I showed you can screenshot a map off this humid heat signal specifically. You can do this with any three of these toggles. So all of that, just pick the one that you want. You can come back up to this screenshot map. You'll get the card that comes along with it. So if you're looking to share this on social media and specifically for Minneapolis, Minnesota, when you come to that screenshot map button, that will come along for the journey as well here. So being on the times more likely climate signal card, you'll get the image, you'll get the data, you'll get everything that you need in the card to share. And you can also, maybe you want to zoom out a little more, you can just use your scroll wheel or your trackpad in order to get the right view that you were looking for there for that specific city.
Thanks, Shell. Next question, I think popped up a couple of times. Again, kind of got answered in the Q&A, but I feel like it's worthwhile for us to say out loud, and it relates to that threshold, that 77 degrees thresholds. Caitlin, maybe do you want to spend some time discussing where that threshold came from, and like some of the science behind it?
Yeah. So this was a threshold that we chose really after a review of the research. And, like we've talked about a lot here, there are a lot of different variables that will determine what your like critical wet bulb temperature it really is. But, looking at across all the research, there's been a lot of stuff done to look in both like laboratory settings, both in review of mortality data. And there's been really these large ranges. And the 25 degrees Celsius, 77, that kind of is in the middle of what we've seen in a lot of these ranges where this becomes a real problem for people across the world. So it can be as low as 19 degrees Celsius. For people who are really, really vulnerable, it can be up to 32 degrees Celsius. And so we're really kind of in the middle there, just trying to just show like the average conditions for people that have been found to be the critical threshold.
Thank you, Caitlin. One question is a question that kind of came up at the very end. It's going to be a question I'm curious for Chase and Lisa to be able to chat about this idea about what and how a state health department might communicate to local media outlets for humid heat. And I think it'd be useful to understand a bit about how let's say if you're in an emergency room or if you're in a medical setting, how does heat come up? Or how is it like labeled for people? Maybe it's a useful thing for when you're trying to understand what actually is, like how is heat being, talked about, or at least if someone is being impacted by heat, does it get labeled down as a heat impact?
Why don't I start the story and Chase can end the story? And I can start the
Perfect.
story by saying we don't talk about it. It's really unfortunate. It is part of the work that we're trying to do with the Medical Society Consortium on Climate and Health is to raise people's awareness during air pollution events or during heat events, what we're seeing coming to the emergency room and making sure that we're counseling our patients about it. But when you're in the moment, right, you are there just to stabilize and treat the patient in front of you. And so we are often not thinking about how these factors play in unless there's a big event happening, like the heat dome that happened in places like Portland and Seattle, for example. But we had an event in 2022. We had a heat dome event. It was Labor Day weekend, and I labored 48 hours over that weekend because that's what you do as a hospitalist. So I was there the whole weekend, and our hospital filled up. Our NICU filled up. There were lots of laboring moms with complications, and I provided that education to my nursing because I know it, but it wasn't something that was both in most of my nursing's consciousness as to why we were seeing more birth complications as a result of extreme heat. There's a lot of work we need to do on the hospital medicine side for awareness.
And what I would add to that is that it was research from Texas A&M a couple of years ago that showed because there's not really a clear conversation or a clear standard there, that the number of heat-related deaths in the US might be 4 times higher than what we're actually counting. And so that's when I suggested contact your local health department, ask them, do you have criteria for this? Maybe they don't, and I think that's a story. And if they do have criteria, what is that criteria? How does that match the research? Because there's this, of course, new paper from Caitlin and the folks at Climate Central. There's also some great research from Penn State University. There's been a lot of different really smart people looking at this and trying to figure out, okay, what is the threshold? And it seems like the trend is almost down a little bit in terms of like what we can safely tolerate. At the same time that climate change is pushing the high end up. So you kind of have like our understanding is moving here, but then the climate impact is moving here, essentially like increasing the threat. Last thing I would just say is like, if you're having trouble getting numbers or quantifying this or tracking this in your local community, again, that's a story. Like just because you're not getting hard numbers, don't let that stand in the way of communicating what the risk is, because Lisa and lots of folks like her in every city across the country that can help you understand what the risk is.
Thanks, Chase, and thanks, Lisa. There's one more question here that's in the Q&A box for Lisa. It's again talking more about this acclimatization. I had all the words I could say, and I chose that when I couldn't say it. But this idea behind like different people in different areas, and whether there actually is a need for there to have different thresholds depending on location for something like a wet bulb or wet bulb globe temperature, and how that gets factored into thought process.
Yeah, I'll speak to my experience, especially with athletes, because it's going to look different. Every employer, for example, if you're running warehouses, like we've started to do some work with some companies to start thinking about this. And that's going to just look different from place to place. And this is where, to Chase's point, we are seeing more and more local heat officers and departments of public health that are playing a role here. And that's where having that really close coordinations to understand what the thresholds are for your particular population are very important. But in terms of athletes, like if you look at the guidance that the American Academy of Pediatrics puts out, we don't put out hard numbers about at this temperature or this wet bulb temperature, this is when you should call practice off, or this is when you should, move your practice, because it's going to vary from place to place. But we do put in some basic principles about the threats of heat and humidity and the need for breaks and for water and places for people to cool down. But it is going to be very locally dependent on how the population is adapted and what that wet bulb temperature is.
And Tom, actually, I can jump in real quick and just emphasize one other thing that that Lisa mentioned is that in Texas and Florida, there's state laws which ban local governments from creating regulations to protect outdoor workers. This was specifically targeted at cities like Austin and Miami, which were trying to protect people who are working outside. And so I hate to say that this is almost certainly going to happen, but especially in Texas and Florida, we're probably going to have people die this summer from heat-related stress. I mean, it's almost guaranteed to happen. And so when that happens, I think there's a great accountability story for local journalists to maybe go back to, I mean, especially if it's your local legislator, and say, you voted for this law that is preventing us from protecting people, and now we have people who have died. And I hate to say that that's almost certainly going to happen, but I think it's almost certainly going to happen. And I think that's a really important story, especially for journalists in those two states.
And maybe this is a question for whoever wants to take it. This idea of like humid heat season. Is there a difference between early season versus late season? Is there a difference between like the middle part of the summer versus, let's say, the periods of time when it relates to impact on human health, whether we have early humid heat versus late humid heat?
I'll just quickly say early is more dangerous because the body hasn't had time to adapt. And you're just not prepared for it. And this is why climate change is so dangerous, is because it's taken, I like Catherine Hayhoe, the way she talks about it, is global weirding. You know, what we expect to be the normal course of events for our weather are completely disrupted. And so the most dangerous is when it happens early and your body isn't adapted and we haven't adapted in terms of our activities yet to stay safe.
And Lisa, can I also ask you a question I've asked other doctors, but maybe just for the benefit of the panel? The difference in like a humid heat wave that lasts a day or two versus one that lasts a week, how does that affect our bodies?
Yeah, so we tend to see, early what you might see are people that are having heat exhaustion because their body hasn't yet been able to adapt. So if they're outdoors, an athlete, for example, can get into trouble quickly. As the days go on, as I mentioned, the elderly get more and more vulnerable as those days go on because your heart beats faster to get blood out to the periphery, and that heart just gets stressed and tired. And so you start to see more deaths from the elderly or those with chronic medical conditions as the days go on.
Thank you. So we're almost coming up at time. I will note that any question we don't get to, we'll provide contact information in the chat, so feel free to send an email out there. I'll also note that you can sign up for our Climate Matters newsletter as well. We'll put that link in the chat as well. And we have maybe, let's say, we'll take this one last question, and then we can leave it at that. Thank you again, all the speakers, for providing your time and your expertise to this. This question is again talking about the different flavors, I would say, of heat and humid heat and their impact on the human body. And that goes to about night heat. Is night heat more dangerous? Does the same go for humid heat? Is night humid heat more dangerous? Is there a timing aspect to humid heat that also plays a role?
I have an idea, but I was going to let Dr. Patel answer first if she would like to.
I feel like I've talked a lot. Why don't you start, Shel?
Well, I was going to say, so one thing that was, I always had a really reiterate, especially, one thing we know about climate change is that the heat is getting more intense, but we know that these heat waves are lasting longer. So one thing that I always tried to relate to my viewers is, I'm in Texas. One day that's really hot and maybe even unusually hot, we live in Texas. We expect to be hot in the summer, but a lot of what we've been finding is that the heat and the humidity have been compounding and going day after day after day. And while most of us at least where I live, have air conditioning, like Dr. Patel mentioned earlier, not everybody can afford to run that air conditioning the entire time. So at least in my purview, and again, I'm not a doctor, I just play one on TV in this Zoom, is that especially those compounding when the humidity is high both nighttime and daytime, and that heat really gets trapped in our homes. That's when it's the most dangerous, especially for some of these folks that can't afford to run the air conditioner 24/7.
Michelle, that was exactly what I was going to say. And I'll drop a link for a piece we did in CNN a couple of years ago now about the fact that, it's hot during the day, but then that heat gets trapped. And it's also because of urban heat island effect, the pavement holds on to that heat and then it ends up back up at nighttime. So things don't actually cool down for us. And as I said, like the nighttime is our time for our bodies to get respite, to rest, to relax. And so when it's hot outside and we're still under stress, our bodies essentially don't get that break.
Thank you, Lisa, and thank you, Shell. Thank you, Shell, for playing a doctor occasionally here on our webinar. But we're coming up at the top of the hour. I want to thank all of our speakers again for sharing your time with us. I will note that this is being recorded, so we'll make sure that this video does go out and will be sent to all of those who are registered. Again, another reminder that the paper that underlies the science behind this new resource, the Climate Shift Index Humid Heat, was published today in Environmental Research Letters. The link is in the chat, and the resource again is now available live for public use. If you have any questions about it, please feel free to reach out to us at any time, whether that's about questions about the tool, how to apply it to your reporting and stories, requests for additional training. Please feel free to send us an email. And if you haven't yet, please sign up for our weekly Climate Matters reporting packages at climatecentral.org/climate-matters. Again, thank you all for attending. Thanks to our speakers, and have a wonderful day. Thanks, everybody.